All right, analog computing is making a comeback, so I thought I'd put together a couple little operational amplifiers for adding and for subtracting, and you can you multiply, you can do integration with them, and so these operational amplifiers, they were made for doing mathematical operations, and now we use them mainly for amplifiers, but they work great for any mathematical operations. I did an adder and a subtractor, and maybe in the future I'll do multiply and do some integration. But what you do need on them, I use an LM 741. You need the power supply has to be dual power supply, and what I did is I used two 9-volt batteries in series with another 2 in series, and then the negative and positive tied together. Here goes to ground, and then we have negative 18 volts and positive 18 volts, positive on 7 and negative on 4 there. Now we get 18 volts out of here, and 18 volts is fine to power these with. I think you can go up to 20 volts if you want, but on terminals 2 and 3 you can only go as high as 15 volts, so you got to keep that under 15, but you can power them with a little bit more voltage there. So 18 is fine on those, and we just have these two. Everything's all 10k resistors on here, and say if you put 5 volts on this resistor and another 3 volts on that one, then on the output you're going to get 8 volts out. Okay, it's going to add those two together. Okay, now the 1 and 5 that's a null, offset null. Okay, and so what you can do is you can put a potentiometer across there, like a 10k pot, and that's used to minimize the offset difference, the offset voltage on these, if it's off a little bit. So you can just short these out, bring them both to ground, and then turn the pot until the output reads 0 there. Okay, I didn't use that in there. That's optional, but we'll see how it works. And then on the subtractor, we have all 10k resistors, and then I have if you put 5 volts on this one and 3 on this one, you're going to get 2 volts out over here. Okay, now this guy Bob Wilder, his designs laid the foundation for modern analog IC circuits, so from the 60s to the 70s, and he designed a bunch of op amps, and LM 101 and LM 10, and he's got a famous quote that and a poster out, and so he says here, digital, every idiot can count to 1. So he was into analog. So yeah, so I have it set up here, and we'll see if it works. So there's my power supply, and then I have these two power supplies here are going to put and then we have to tie the positive rail and the negative rail. Okay, and then since we're analog, I'm using a couple analog meters here. Okay, if we can see those. All right, there we go. Maybe push them up a little bit higher. There we go. Now I'll turn the power on, and over here we have 5 volts on this one and 3 volts down here, and so on this op amp here, the adder, we should have 8. Looks like 8, close to 8, and on this one here we should have 2 volts on there, and right in the middle is 2.5. It's a little less than that, so it's close. These are cheap meters, but yeah, we're it looks like it's working out all right. So that's a analog adder and a subtractor. So yeah, analog computing is a thing, and they think it's coming back. Anyway, thank you.